Algebra 2, we are now in Lesson 1, starting on page 21. We'll be dealing with polygons, triangles, transversals, and proportional segments. In 1a, we basically defined what a polygon is, and you'll notice that there are several shapes that are given. The first polygon that is available actually is in the shape of a triangle. And the reason is because it's defined by more than two angles. And so if you have 1, 2, 3 angles, the triangle is the first polygon, okay? And you'll notice on that page 21, there's the triangle with 3 sides, quadrilateral with 4, pentagon with 5, hexagon 6, octagon 8, and so on. And it demonstrates those examples. And you'll notice that the sides, in order for it to be a polygon, the sides do not have to be the same length. So you would typically see a polygon as, you know, if we want to see it symmetrical, we would like to see it in a square where all the sides are exactly the same. That is a polygon because there's more than 4 angles, but it doesn't necessarily have to be a regular quadrilateral. This would be irregular because you have 4 different lengths of sides. This one, this one, this one, and this one. Okay, so it demonstrates this on page 21. If you turn the page to 22, you're going to notice that it even gets more detailed as far as describing what a polygon actually looks like. And we have terms like cave and equilateral and equiangular, concave, convex. All right, so I want you to look on page 22 and read that page because it's all informational about the types of polygons, okay? So there's nothing really that we're going to do mathematically with these. It's just all description. 1b begins kind of our work, all right? So in 1b, on page 23, we have a right triangle, which means that we have a square in the corner. We have an obtuse angle, which means that it's greater than 90 degrees, okay, 90 degrees plus. And then we have an acute angle, which means that this angle, and if we want to finish that, okay, these angles are smaller than 90 degrees, okay? They're less than 90 degrees. You'll note that within any triangle, the interior angles total 180 degrees. All right. If it's a scaling triangle, scaling just means that you have 3 different lengths of a triangle. If it is an isosceles, it has 2 of the same lengths, but the third one is different. If you have an equilateral, that means that every single one of the lengths is exactly the same length. Okay, so that is essentially 1b. Now, we're going to do some math with this, and I want you to go to the next page where you're going to see 1.1. And you're going to look at an example that looks like this. So you've got an isosceles triangle, which means that 2 sides are exactly the same, okay, because of those tick marks. This angle here is a 50-degree angle. This one is x, or excuse me, I guess that's y, and this one is degrees x. Can we find out what the other 2 angles are? This one and this one. Well, yes. If these two lines are exactly the same, that means the angles opposite them, okay, are exactly the same. So x degrees then is going to equal the same as this over here. So that's 50 degrees. And if we know that the total of the triangle equals 180, we can say 180 degrees minus 50 will give us the total of this angle. All right, so what is 180 minus 50? We have 130 degree angle, okay, on top. That's what y is. All right, so not too difficult to find out those examples or those answers for that. Let's go to the next example. You're going to find that on the same page, just underneath it, and you'll see something that looks like this. You're going to see a scalene triangle, okay, which means it's got 3 different lengths, right? We'll label this B, y degrees. We want to find out what x degrees is, and they give us this. They say that this is 150 degrees. Can we find x and can we find y? All right, I guess they do give us one more, which is important, 40 degrees here. Okay, so if we said that this full angle is equal to 180, if we have 180 minus 150, we can determine angle x, which is 30 degrees, okay? X equals, or degrees, x equals 30 degrees. So if we have 30 here and 40 here, 30 plus 40 is 70 degrees. And if the total inside is equal to 180, then we can find y. So 180 minus 70 will give us 110 degrees. That means y equals 110 degrees. All right. I think it's easily understood. If you have questions about that, you can either replay this or you can come ask me your questions concerning that. Let's go to 1C. All right, 1C is dealing with transversals, and essentially transversals are only parallel if they have a unique look to them. Okay, and I'm going to show you the difference between parallel transversals and a non-parallel transversal. Okay, if you have arrowheads that are on every single line here, it means that those lines are independent and are not parallel. The look for parallel is, let's say we name this line A, this line B. So A is not parallel to B. Okay, parallel would be those two lines next to it. So if I was saying, okay, in this one, C and D, there's a unique look to this, okay? If I have arrows that are hidden inside those, okay, inside the line, like inside, not outside the line, then I would say C is parallel to D. And I know this because of those two lines. They are said to be parallel. So this distance here is the same as this distance here. Now, because of my drawing, maybe not, but you get the idea. All right? All right, let's look at an example of a transversal in 1.4. All right, 1.4 gives us a transversal, and we have two parallel lines. We know they're parallel because we see these little arrows in the line, and the transversal is the line that actually cuts through that, okay? C degrees, B degrees, A degrees, and then it gives us one known, and that is 60 degrees on this side. If this is 60 degrees, the opposite is also 60 degrees. And if this and this is true, then this has to be 60 and C has to be 60 degrees. So C is going to equal 60 degrees. Well, that's great, but we have other ones to figure out, okay? So if this is 60 degrees, right, we know that this whole line here is equal to 180, so 180 minus 60 degrees will give us this portion, okay, which we need because B and A are both opposites of that angle. So we want to find that out. What is that? Well, 120 degrees. So B equals 120 degrees and A is equal to 120 degrees. The nice thing about parallel lines is that their angles are also the same. All right? So that's how you can find transversal angles without too much of a problem. Let's continue on, turn the page, and you're going to find on the next page a transversal that looks a little bit more, I guess it's 1D, it's called scale factor, okay? And scale factor, I'm going to use SF as an abbreviation, okay? If you turn the page to 26, you're going to see 3 parallel lines. Each of those parallel lines have those arrows embedded in them, okay? And there are 2 skew lines, another 2 transversals. One is kind of straight, the other one is very kind of skewed, and it's obvious. This is labeled 2, this is labeled a distance of 3, this is 3, and this is 9/2. How do we find a scale factor? Well, we can go from right to left to find scale factor, or we can go left to right to find scale factor. And in your textbook, it talks about how to find the scale factor, okay? So if I look at these things, okay, if I look at the scale, in the text it says the left to right scale factor is 3 to 2. And you'll notice that the arrow is this way, okay? From left to right. All right, 3 to 2. Okay, if it was the opposite, if it was right to left, it's 2 to 3. Does it matter, left to right, right to left? No, because they're both proportional, okay? So I can use this to my advantage to figure out different numbers. Like, for instance, if we didn't have 9/2, could we come up with that number? And the answer is yes, because if we said 3 to 2, we could say 3 to we don't know, all right? So in other words, if we didn't know this and we used, okay, we've got this 3 and this 2, and we're going to use this first one. So our scale factor is 3 to 2 is equal to, we don't know, we don't know this one. In other words, excuse me, to we don't know, and this is 3, I'm sorry. And the reason we do that is because we're going left to right, okay? So 3 to 2 is equal to, we don't know, over 3. And we can cross multiply. That means we have 2x equals 9, divide by 2, divide by 2. Guess what x equals? 9/2. So we can actually find this length using the scale factor. And that's exactly what your textbook has you do. It has you find those scale factors, okay? So in your practice sets, you're going to see that in practice 1.5 is another scale factor. And the scale factor that they do here has a couple of unique looks because it uses fractions instead of whole numbers. And so there is maybe a little bit of a question, like how does this actually work? Sorry, I gotta get rid of this. So let's look at it, okay? Here's the transversal. One row here, one row here, and we have one down here, all right? Here's one, and then the other one looks like this. All of these have arrows inside, okay? And I'll let you look at that. This is 2, a value of 2. This is a value of 5. This is a value of 8 over 3, and we don't know what that one is, okay? In order to find this, I'm going to use the right to left method because that just makes sense. Because I read that way, I think that way. So what I like to do is remember that scale factor is right here. So I can say 2 scale factor equals 8 over 3. How do I get scale factor by itself? I divide by 2. I divide by 2. Now, how do I divide a fraction? Well, if you remember in algebra, we flip this fraction and multiply. So really, my scale factor is equal to 8 over 3 times 1 over 2. Okay? And that's exactly what you see in this problem. So I can cancel out here. I could say 1, and I could say 2 divided into 8 is how many, what does that equal? Well, it equals 4, because 2 times 4. So 4 over 3 is my scale factor. Now, what does that mean? That means I can apply it to this x. In other words, I can say that 5 times my scale factor, which I determined was 4 over 3, is equal to the value of x. So how do I do that? Well, 5 is over 1, literally, so it's 20, okay, 5 times 4 is 20, over 3. That is what x is equal to, so my value here is 20 over 3. Okay, I know that might seem a little bit tricky, and you're going to have some examples in your text to do, and that is great. What I'd like you to do is look at number 4 in your actual lesson. Okay, I'm going to help you with number 4 to find x. All right, here it is. We've got 4 transversals here, and don't let these lines, trick you. It's just to show that they're parallel. Okay, all of them have arrows in here, telling you that they are parallel. Here's one, and here's one. Actually, it goes the other way, doesn't it? Let's do this in red. Okay, there's one, and there's one. Okay, go back to my ink here. This is 3. This is x. We don't know what x is. This is 2. And this is 3. So we're going to use the scale factor of our knowns. This is our known, okay? So scale factor is 2 scale factor equals 3. Get scale factor by itself, we divide by 2, we divide by 2. So scale factor is equal to 3 over 2, or 1.5, okay? Can we apply that to this? And we can. So what does x equal? Well, we are going to multiply 3 times 3 over 2, which is going to give us x. What does that equal? 9 over 2. 3 times 3 is 9 over 2. X is equal to 9 over 2. We just solved for x. All right? So that's how you do those problems. There's number 4, and I hope that helps you in your lessons to follow. Okay? If you have any questions, let me know.